Hello, everyone. Welcome to our webinar on 5G Standalone Security. Firstly, a big thank you for your interest in the topic and joining us today in this interesting discussion. To begin with, I'm Sonali, your host for today. And before we get into webinar topic and the speaker details, a few points I would like you to remember to ensure an engaging and interactive session throughout this webinar. Now, firstly, through this discussion and webinar, if you may have any questions, queries, or you may come across some technical glitch, do not hesitate. Just drop a note in the Q&A in the chat window, and me and my team or backend experts will be there to help you with that. Secondly, while we have parked about 15 minutes towards the end of the webinar for a Q&A, which is a dedicated time for the Q&A session, I will strongly recommend that through the course of the webinar, through the series of slides that you will go through with our expert team, if you may have questions, if you may have some suggestions, or may want to know more on those points, I would request you all to put your questions down in the Q&A window. Now, by this, what will happen is firstly, we'll get some more time to address your queries, and we can also answer more questions that you may have. Now, thirdly, the most important point is we are going to be sharing a recording of this webinar post the webinar session starts. So now you can sit back, relax, and enjoy the insightful discussion on 5G standalone. But before that, a little bit of an introduction. Today, as a lot of y'all experts and telecom fraternity people know, we're going to talk about 5G standalone, the core network security, the SPA concern, and most importantly, the insightful research that our research team has dug out on, the NFR manipulation, and a lot more exciting things for y'all, the telecom fraternity. So without much ado, I would like to call on my team of experts, Igor Pigalitsan, a telecom security researcher, and Gustavo Conte, our head of pre-sales, to take you to this insightful session and webinar. So over to you guys, and the stage is all yours.
Thank you, Sonali. So let's move on. And hi, everyone. Thank you for joining us today. We would like to present you our new research that described completely new type of attack that related for 5G network, which allows intruder to disable network function that he specified or intercept the signal traffic for the whole system. So we will consider in more details the techniques and background of this kind of attack, what measures will prevent such scenario on production live network. So as usual, a few words about who we are. So I'm Igor Pigalitsan, 5 years in telecom security. Also, I'm working in a position as telecom security expert in security gen. In our company, I also conducting telecom security assessments in 4G and 5G network for our customers, mobile network operators. And Gustavo, please, over to you.
Thanks, Igor. So I'm Gustavo Conte. I'm in this market for over 20 years, currently working as head of pre-sales at Security Gen. But my previous experiences including work at least over 10 years in mobile operators, by assembling blue teams, designing security networks, and that's the angle I would like to add today. So try to look at this research from the side of the network operator and see what we can extract and apply on the day-to-day basis.
So thank you, Gustavo. And let's go to the next slide. So before we move on the main topic of the webinar, I suggested briefly talk about the security of 5G network, why it is so important, and also refreshing our memory, some knowledge of several key techniques that used in 5G. This will be useful for us just to better understanding the methodology of attack. So, as you know, all market participants are concerned about the security in 5G. So, from vendor to local regulators in each country. we see from year to year that more tools are being developed to classify attack and threats for 5G. So as for example, the Europe Cybersecurity Agency developed threat landscape document where they classified vulnerabilities and security controls for each part of the 5G ecosystem. And also America's Cyber Defense Agency also concerned about this topic, and in their reports they say that even if US data and networks are secure, US data that travels overseas through untrusted telecommunication network is potentially at risk for interception, manipulation, and disruption from third-party companies in other countries. And all these facts confirm that the security topic is only gaining momentum right now in regular authorities, and all market participants will somehow have to implement mechanism to ensure the proper level of security. Yeah, let's go next. And so before we move on example of attack analysis, let's refresh in our memory a little bit about how 5G network works and what the key features of this operation comparing with the, let's say, previous generation network. If we take a look at the core scheme for 4G and 5G, we see that in the right scheme for 5G, almost all elements are united by the common interface that's called source-based interface. This means that all network functions and their services are located in the same network segment, and they will communicate with each other. The main position here is occupied by NRF. It's a network repository function, which acts like a database for all connected network function. So all network functions placed in 5G core, and NRF stores their profiles with a full description of network services. Let's now look at communication model of the network functions among themselves. So the most popular scheme is shown in this diagram. The other options assume communication scheme directly between two network functions or through service communication proxy. We haven't seen this option in production network, at least for now. So the first stage, all network functions must go through the registration procedure in NRF. For this purpose, all network functions performs put request. After that, if one network functions wants to contact to the second one, the first executes request to detect the other network function in accordance with the certain parameters that are specified in the fields request, such as slice ID, name of requested services, and many other. If NRF return several profiles, consumer initiate NF selection procedure and according to internal policies. So then consumer consent request to selected NF producer, and after that, these two network functions just continue to communicate with each other until the lifetime of these profiles will not expire.
Igor,
So, yeah.
sorry to disturb. Just one point. So what you have shown is that the network functions, they can communicate freely between each other in a, let's say, in a network connectivity point of view. But once this connectivity is granted, the only, let's say, function that regulates this communication would be NRF, right?
Yes, right. To be honest, release 15, that was the first one, assumed that network functions can communicate without NRF, but also we don't see this option in a real life network in operators. Any other scheme assumed that NRF is the main and certain network functions that regulate all the communication in SBI interface. So yeah.
Okay, thank you.
And actually, understanding this principle will help us to figure out the attack pattern from our research. So why it is important for us. And also, when we're analyzing new vulnerabilities, we must clearly define assets that may be affected, assess the risk. We should take care about the consequences of the attack, what kind of measures needs to be taken to prevent such a scenario in our network. And for this kind of analysis, new tools such as Mitre Fight and the smart motive framework were developed just not so long ago. And we find this framework useful for us. And we suggest just getting to know the first one more closely. And that's called Mitre Fight framework. Mitre organization that actually develop, as you know, threat intelligence frameworks of adversary behavior for enterprise, industrial control, and mobile systems. Already has developed a framework for 5G that called Fight. It was 2 years ago. This matrix is set of the tactics and techniques that can be applied by the attacker for 5G mobile networks. And Fight is based on a combination of theoretical, lab-proven, and real-world observed techniques. Authors defined 4 primary user groups for this framework. The first one, it's mobile network operators can use this framework just to better defend against adversaries. The second one, it's anyone who involved in a product life cycle, like software vendors, like service providers, like IPX. The third one, it's enterprise users of 5G networks can also use this framework just for risk evaluation. And finally, security researchers, which in fact we also find this framework useful for us for such kind of analysis. This is what matrix looks like for now. As you can see, the structure looks pretty similar with the classic attack matrix. This is just a table with the columns called tactics and rows, it's techniques, as well as Mitre attack matrix. Some of techniques has sub-techniques. Also, some items moved from original matrix, and the rest techniques is unique for 5G. Also, the website by themselves, it's a common platform, and we can also find section here dedicated to detection and mitigation against attack.
Igor, just
Yeah.
one point. You told us Mitre is developing these last 3 years, and this year we saw also that GSMA Fraud and Security Group has included and referenced this study on their own materials. So do you believe Mitre will be deepening down these studies on telecom security? What do you expect for the future of this scheme?
Yeah, we see that GSMA also develops some threat intelligence tools for the attack analysis that's called Motive. They actually based on internal research, and a big part of this framework just closed for the rest of telco communities that not in GSMA. Yeah, for now we see that Mitre Fight is more common framework, and also they have some backgrounds with the mobile industrial controls, and we see that they updated this framework, and yeah, we see that it will be the common one. So actually, how we can apply this framework and how this framework can be useful for us and everyone who involved in telco security. The first one, it's United Language for security and network professionals. The second point, let's say during assessments, professional can use Fight matrix just to conduct a security gap analysis, identify what defense you have in place and where you're lacking. It's also helpful to review your existing security controls and solutions to ensure that they cover all the tactics and techniques. The next point is about prioritizing controls. You can align your security controls with the Fight techniques that are the most relevant to your industry field. Next point is about threat detection and incident response. So implementation security information and event management system that's aligned with the Fight helps just to facilitate real-time monitoring of security events. The next one, Mitre Fight framework as knowledge base of adversary behavior helps to train your red and blue team. Like your blue team can use Fight to identify defense against attack. And the last point about vendor evaluation. Actually, as a company, you can use this framework to compare your capabilities of different security tools. And so we have given just right now only examples of the possible use cases of this framework. So you can define for yourself the areas where the Mitre Fight is also applicable for you. And now let's try to apply the described framework for analysis, real-time attack in 5G. We will consider, we will go through the main stages of the attack and consider what techniques should be applicable for that. And I should say that the final goal of the intruder in our case right now, it's performing denial of service attack of the victim subscriber. First of all, I should say that preparatory part of the attack takes, let's say, most of the attacker's time. The preparation period includes such tactics as reconnaissance, resource development, and initial access. Let's start with the first one. For the beginning, attacker conducts reconnaissance of the mobile network operator. So to do that, he should discover IP addresses of 5G core elements. Basically, it's enough to find the address of network repository functions, as we said before, since these network functions are storing all the active profiles of 5G network. That actually works in our standalone core. Then our intruder also needs to prepare some tools just to carry out our successful attack. There are many ways to do this, starting with generating your own framework in any language using Open API specification, or you can follow a simple way like using popular testing tools like Burpsuit or Postman. So at the next stage, the adversary should think about the attack vector on the victim network. He can get into the network through compromised roaming partners, for example, and also roaming partner. It's important attack vector even through the encrypted tunnel. Attacker have some possibility to send malicious traffic that can be affected your network. Or even more, the attacker may already be in IT infrastructure and then using various methods gets into the signaling segment in the operator's network directed to the service-based interface.
Igor, so could be a lateral movement, but could be also from a server that is connected to any of these functions, right? So maybe some billing function, maybe some, I don't know, management system, whichever that has access to one of the functions. If you go for it, if you enter and let's say control one of those functions or have access to the network segment, this would be also an initial access point.
So yeah, potentially our attacker he have let's say access to the SBI interface. He can affect any other network functions in this way. So like PCF that's also aligned with the billing system can also be affected in our example. Yeah.
Okay, thank you.
So next, intruder conducts exploration of the network which he finds himself. So by getting all network functions profiles, using these profiles that adversary received from NRF, you find out the address for all deployed services. And at this stage, the attacker knows the entire network structure, which services are active, what version of API is used, and any other information related to the network functions. And further, after collecting the necessary information about the current session of the victim subscriber, we can just proceed with this attack. So in our example, adversary is trying to release existing packet data in its session by setting request to SMF. So after that, the SMF sends request to AMF just to close current subscriber session. And here we can see execution of this attack. SMF responded with 204 code, as you can see. In this way, the subscriber has lost connection to the internet and IMS network as well. So calls were unavailable until the subscriber is connected to the network again. Usually, reconnection takes 1 or 2 minutes, but at the same time, attacker can automate this process of collecting data about new created subscriber session and sending release request. By doing so, the attack will be unlimited amount of the time. So, and yeah, in this diagram, we see in more details the final step that was performed by the intruder that we described just now. For the purpose of the attacker, just was to deny the subscriber of internet connection and IMS, and we were able to reproduce this example of attack not only in our lab stand, but also on an actual production network. In this way, we just considered how threat intelligence tools such as Mitre Fight can be applied for attack analysis. So we just remembered some of the procedures related to NRF workflow. We get learned about threat intelligence framework and look at how we can use it as a part of attack investigation. And I think now we can move on and talk about new type of attack that were discovered not so long ago and recently we are published in our white paper. And the main idea of this attack is that intruder manipulates the profiles of network functions, which leads to change in a configuration of 5G network. And for the beginning, a few words about what are the prerequisites for this attack and why it can be happened. And the first point is about flexibility that actually embedded in 5G architecture. We have partially talked about the fact that NRF is a kind of hub for all network functions profiles located on in our network, and this provides flexibility and usability in setting up and maintaining of the network, but at the same time, this is very risky from a security point of view. And having access only to NRF, you can manipulate the configuration of the network, as we will show you later. And the second reason why attack of this kind can happen is that almost all operators are not in a rush to introduce network security measures such as authorization and authentication that provided by the architecture itself. This can be explained by the fact that implementation of such measures is more expensive and inconvenient for maintenance for MNOs, or sometimes we see that suppliers' equipment does not have the appropriate security features. So we make this observation based on our experience of conducting 5G security assessments and open statistic was used. And now let's move on and go through the attack steps. And at this stage, the attacker has already gained direct access to the network and has IP access to the SBI interface. So then, by executing get NF instance request, you can just extract list of the registered network function. And on this slide, we see the example of execution such request. In our response, we received 200 code with the data part, and there we can see the unique URL list with all network functions that get a registration in NRF for now.
Igor, one point.
Yeah.
So you perform this kind of tests, security assessments on 5G network, live 5G networks. So when you do this kind of reconnaissance step, you get the network functions list. Usually you get detected. So we have a feedback from customers that somehow they received an alarm or anything on this step of the security assessment, or it just goes and no one is aware of it.
So yeah, usually we are not detected in this way. So I have some examples when we were detected by the equipment, and this equipment sent some alert to the SOC system, and they catch us with that. But it was when we, let's say, perform some manipulation with the real subscribers and create massive deregistration for the real subscribers. Yeah. But if we performing such requests like get, usually equipment do not have sent some alert to the system.
Okay, thank you.
Thank you for the question. And the next step for the attacker, currently have only NF instances IDs list, and using this ID, you can then try to get profiles of the network functions. In order to achieve this, he needs to execute the following examples of serial request, namely get NF instance ID, where in fields he placed IDs from the list that was get before. And here we can see one of the example of request execution of such kind. And as a result, we get whole profiles of requested network function. On this picture, there is a profiles for SMF, as you can see. Also, this profiles contains fields such as NF instance name, NF status, IP addresses, slicing information, and many other fields. And the last step, the attacker is able to replace some fields in the new discovered profiles. For this purpose, intruder simply update profiles by doing it using put or page HTTP request. Because of this substitution, you can expect various impacts for 5G system from a massive denial of service attack on a specific node to man-in-the-middle attack with interception of the signaling traffic of all serving subscribers. And so now attack can replace the IP addresses with the address of the hosts that for now is under his control. And let's say if he deployed the proxy there. So in this way, he simply redirects the traffic that comes to this host to the host where his real SMF is working. It's or in a simple way, attacker can set up other IP just to performing the null service stack. So in this way, once new network functions proceed with NF discovery procedure, these network functions will receive from NRF wrong profiles with our new IP. And as we already noted, there are two options for the impacts of this attack. The first one related to denial service, where intruder can disable a certain node or all 5G core elements. Moreover, the entire network will not work and subscriber will not be able to connect to 5G network. Or on the other hand, if attacker perform man-in-the-middle attack, he is able to see all signal data and he can change it and manipulate with the data what he wants. We already talked about the stages of the attacks and the impacts, but what about protection against this activity? The first thing that comes to mind for the most experts is, of course, to deploying security edge protection proxy, SEPP. So many of SEPP do not have required key features such as traffic filtering, supporting of Prince protocol, and topology hiding. The fact is that SEPP only works on a border of the roaming connection and encrypts the tunnel between his roaming partners. But if roaming partners or any third party that involved in roaming communication, if they compromised, attacker could exploit this to access the MNO infrastructure, even through this encrypted tunnel. And the encryption safeguards only the transmission path, not the data or the system. In such scenarios, relying solely on encrypted communication, such as SCPP, is clearly insufficient. And MNOs must implement additional security measures just to mitigate these threats. And such measures should be, first of all, to be integrated of authentication and authorization into SBI. Because as we see in the practice, there is no examples where MNOs deployed these security features in their networks. And as we discussed, operators should implement traffic inspection and security monitoring on the roaming interfaces. And we should also remember that attackers can send messages that are difficult for detection. So protection tools should be able to get into application level. That is actually HTTP protocol in our context. And another step to build a secure network is to perform regular security assessments and analysis of the threats. This measures allows timely identify the vulnerabilities that have arisen during network operation. And of course, engineers who are engaged in the maintenance and configuration of the equipment, as well as cybersecurity experts, should also have the necessary knowledge base regarding 5G security. So this is our, let's say, vision and recommendation just to protect against this kind of attack.
Igor,
And
if you can get back to the slides, just a question of
sure.
mine. It's that we listed a set of mitigation acts. So it's not we can just put a magic box over there and solve it, monitor and filter it for the customer. So there is a lot of actions, constant actions to be taken. I understand that. But when you say that, okay, we should do inspection and monitoring on roaming interface, we could also, let's say, extend it a little bit, right? Because not every interface to SPA is roaming. You may have, I don't know, private networks connected to your SPA and other, let's say, borders. You would recommend inserting monitoring on those borders as well?
Yes, for sure. As you said, let's say 5G infrastructure has a lot of corners, and if we want to cover all the aspects of 5G security, we need to take care about all of the aspects, and should think about all of the angles where we can apply our security measures. Yeah, you're right. So that's all from my side today. Hope this information was helpful for you. And yeah, if you have any questions, please go ahead.
So Igor, thank you so much for the presentation. We do have some questions. I have inevitably already did one of the latest one, because I had the same question as our audience. So about the private network, I believe it's being answered already. But I will start from my collected questions, also from both LinkedIn and the session here. Your question may look a little bit different. I may reword it a little bit, but we will go through all of them. Thank you so much for your contributions. So first question we have from the audience, Igor, is, does the specification confirm that NRF, like network repository functions, will not respond to a discovery request from a network function unless it first verifies the local policy? So is this mandated by the specification?
Yeah, it's kind of mandatory step just for let's say normal work of the 5G ecosystem. And yeah, as I said, we have at least two other options for the communication model, but it requires to implement service communication proxy inside the network, and some of the requests can be handled by this SCP, but at least we don't see any implementation of this communication model in a real network, at least for now.
Okay, thank you. So we have another question. Is it possible to use the Mitre framework to study the threats and exposure of the network to risks, such as location tracking, eavesdropping? So can we use the framework to, let's say, to do a preventive study on the networks?
Yeah, let's say such kind of threats that's related with the location already described in Mitre Fight, and for sure you can use this matrix just to be sure that you are in place with 5G security and check your security controls that you already applied in your 5G system.
Thank you. I'm not naming. I appreciate everyone that sent questions. I'm not naming for privacy points, but this one has come from LinkedIn. So how we can effectively prevent the launch of rogue network functions, right? What security measures or best practice should be in place to detect and mitigate these unauthorized or malicious functions in the network?
Yeah, this is a good one. So actually, here it is. What kind of mitigation we can suggesting to apply in 5G network? The first and the main one, it's about let's say deploying authentication and authorization, applying open authorization to .0 protocol into the network and apply TLS and protocol to the SBI interface. So yeah, this is the main one because as we see in the practice, operators do not implement such kind of security measures into the 5G SBI. And we know that some of the vendors actually do not have support such kind of features inside the equipment.
Okay, another question, right? You mentioned here that likely when we have these attacks on 5G networks, they go undetected. But usually, cellular networks, the mobile networks are well monitored, right? They have a lot of alarms and quality KPIs, etc. So why is that we don't see the same level of monitoring precision on detecting this kind of suspicious behavior or this kind of threats? What's the gap, as you see?
Comparing with the previous generation network, the main gap here is that 5G is more flexible for third-party connections. Like, for example, we can include Open Gateway inside our 5G network. So yeah, the problem is there that we have much more attack vector for our infrastructure. That's why we should take care about all the say angles and protect all the holes in 5G.
Okay. There's another question here about regarding security roaming in 5G. There is ongoing discussion in the industry suggesting that the recommended security implementation that is being proposed by 3GPP may conflict with business interests of IPX providers who offer value-added services. Is it true that secure roaming is being delayed or hindered because of this conflict? If so, what can be done to balance security and business interests? I would like to take this one, Igor, if you allow me, because
okay, for sure.
it has a more commercial side. So, well, we have seen that. So what we see is that there is a business issue, of course, because if you encrypt end-to-end, as 3GPP has recommended, then IPX providers, they will be blind to your traffic, which is a good, it's good for security, maybe not as good for business. And if you have some features hired, etc., they won't be able to fulfill it anymore. Also, another blockage of it is that you need to exchange keys and interact with many more entities, right? You should encrypt between each mobile operator in the world. They should share keys and share some data in order to connect straight to each other with other, let's say, business impact, because you need a much bigger team to relate with as many players as well. So I understand, yes, it's causing some delay. And of course, there are, let's say, some compromise solutions possible when you at least encrypt between the operators and their main IPX providers, and they should encrypt between their pairs as well. So this is something we are waiting for the market to define, but it's let's say part of the issue as per now. So we should be seeing how it will be, let's say, the final architecture for IPX interconnection on 5G standalone. Another question here. So many organizations are not openly disclosing breaches. From your point of view, what the type of attack is most likely to occur in 4G and 5G networks? So what we see happening or understand is happening the most?
For now, we also don't have, let's say, as you said, we don't have open statistics regarding that, but based on our experience with the previous generation network, many of the attack targeting, let's say, the fraud into our subscribers. So the attackers is trying to, let's say, perform some malicious activity with balance, with fraud, with online banking. So, and we're expecting this kind of behavior even in a 5G system.
Yeah. So, well, I have a lot of questions. Thank you everyone for those. Another question. From MNOs that have attempted to implement SEPP, I have heard that SBA couldn't handle the additional payload overhead. So how this issue is being addressed? And you have the SEPP in place, and maybe it will just be disruptive to the SBA.
Yeah, this is a good one. Actually, we also don't have open statistics regarding that, but yeah, let's say for MNOs, it's pretty expensive to implement such as security issues like SCP, SCPP. So let's see how the operators will handle this, let's say, problem. Because yeah, security implementation will take a lot of budget from the operator.
Okay, thank you. We still have some. So another question on GTPC. So how can GTPC or diameter signaling storms, on like control plane storms, be mitigated? Can next-gen firewalls effectively handle this? I've taken this as well because it's like feature related or product related. So yes, we've seen some possible attacks. Diameter is known thing. GTPC is more recent, but they are both valid preoccupations for our customers. And yes, next generation fires can identify and throttle or reduce or even entirely block this kind of storm. So this is something you should be looking at. Another questions? Also from the audience, thank you so much. Do we have any recent examples of network attacks originated from handsets or specific handsets applications on 5G networks? In another way, how likely do we predict attacks on subscriber sides? Can you share some examples of this kind of attack?
Yeah, this is attack vector considering by the community as the main one, because anyone has the phones and you can just send some request to the your 5G system if you knows how to handle this let's say, message. But yeah, we see some example of the current research from, let's say, other companies that manipulate with the NG application protocol and send some malicious request to the malformed request to the 5G system. And once AMF receives this request, he can just broke up. So this is a very significant, let's say, attack vector, and we also take care about it. Yeah, if you want, we can send you some recent research in the private messages.
Okay, I see just one last minute. I think we have time for this. The one last minute question on LinkedIn. If you have any special findings regarding cloud infrastructure, either docs, Kubernetes, that's used to run the network functions. So I understand what customer is asking for. Do we see some specific threats on the virtualization infrastructure?
If you're talking about virtualization, actually, yeah, all the 5G system based on the just developed with such tools that applied with the virtualization, and actually all the common sets that comes from the IT world is also applicable to the 5G ecosystem, because we are using the same stack of the protocols, or the infrastructure, or the any other instruments. Yeah, the attack vector is pretty the same, and the threats is also comes from the IT world.
Okay, thank you so much, Igor. Those are the questions I believe we have for now. If you have any pending ones, we try to address in a one-to-one basis with customers. But thank you so much for the presentation and for the answers.
Okay, thank you.
All right. Thank you, Igor. Thank you, Gustavo, for a lovely session on 5G standalone research and insights. And thank you, everyone, for being such a patient and interactive audience. And as promised, we're going to share a copy of this webinar with you soon after we have the recording with us. So let's stay in touch and keep watching the space for more interesting and insightful webinars coming up in coming months. So thank you for now and take care. Bye-bye, everyone.
Thank you, everyone, for joining us. Bye-bye. See you later.
Yeah, bye.